So before I get going, I just wanted to ask a quick question. It's probably a stupid question since I just spent a couple of days evaluating a bunch of presentation submissions to Postgres India, and it had, I swear to God, 50 submissions that involved PG Vector. But who here has either used or heard of PG Vector? Okay. Have you made anything with it? No? Okay. Well, it's not easy, so let me just start right there. And this whole presentation is going to be on PG Vectorize, which is an extension from the company I work for named Tembo, in an effort to alleviate that particular issue. So that's the company. We do a lot of weird stuff, but mostly we like to boast about our stacks, which are basically just a bunch of Postgres extensions that work well together. So we kind of bundle them, and we've got a free hobby tier you can play with all the stacks to kind of see how they work together, and even make a quick demo app on your own and see how it works before you start building something in production. I hear it's nice. This is me. I do a lot of stuff. I've been working with Postgres since at least 2005, exclusively. This is probably my 20th conference, and roughly about that many times I've been a speaker. That book right there is mine. It's in its 3rd edition, and I had to stop writing it because things have moved on to a point where high availability, I believe, it's just been deprecated, I think. And my conference presentation tomorrow will get into kind of why that is the case. So what is AI? I'm going to go through a little bit of kind of background, not too much because I only have 20 minutes. You might think of this like a big robot thing, and it's an elephant because Postgres, right? But it's not. It's actually that. It's just a bunch of math. And if you know how large language models work or generative AI, that literally is all it is. It's very, very easily, it's easy to fool you though, because it looks like it's thinking. It looks like it's real. It's very convincing. At first, before I started like actually looking into a lot of this, I certainly was fooled. Not fooled necessarily, but it's definitely a lot different from the expert systems we used to know and love back in the day, if you're familiar with those. It's not ELIZA. So, large language model, I'm going to go through some vocabulary first. This is what AI is. And I'm only going to use terms that I use in the rest of the presentation to keep it simple, right? So an LLM is a large language model. That's all I'm going to say for now. RAG is retrieval augmented generation. It's one of the techniques for producing output in a way that's useful to users. Let's leave it there for now. All right, now we're going to start to have some fun. A token is a word chunk. People wonder why not the whole word. Stemming is the main reason. So like, think could be thinking. It could also be extrapolated into thoughtful. Lots of different ways you can break it up. And the stemming basically is how the large language model builds its knowledge. It breaks words into parts and then uses probability to decide which word part comes next. And that's how it actually does all its thinking. And that's why I use the array picture, because that's literally all it is. All right, the next term is an embedding. Oh, that's not right. That's better, yeah. So vector to token coordinates. That's nice, nice way of putting it. But really, I use this for a reason, right? Because it's just a big ass array. And when I say big ass array, I mean hundreds or thousands of elements long, right? We're talking, Euclidean geometry is like maybe 3 or 4 coordinates, maybe 5 if you're getting fancy. Large language models regularly go over the 5,000 mark. So you start getting into the realm where it's essentially becomes holographic because every vector influences every other vector as far as what the relationships are between them. So it's interesting how they function that way. Next is a transformer. They take text and turn it into that big ass array. Basically, you're trying to figure out in the large language model's corpus of knowledge, if you present it some text, where that text will show up in that big mass of knowledge. Because you've got not just one vector. A large language model is a compilation of billions of vectors. And so the goal of transform is to figure out, given some text, where that text would show up if it were turned into a vector in that large language model. So that basically tells you what kind of information is related to it, and that's essentially how they work. I'm not going to go any deeper than that. So when I say coordinate, what does the coordinate actually mean? And I like using this analogy because what we're talking about is each one of those fish, it's not just the location in the ocean, it's also the color, it's the relation to all the other fish around it, it's what it's currently doing. Like any metadata or other information you can use to describe that fish is also encoded in the vector. And that's part of the embedding. And that's true for every single fish, every single bit of wild life you see in that oceanscape. That's basically what a large language model is. And when you're describing a vector, you're basically pointing to something on that and saying that. And then you're starting that as kind of like a seed. So what does pgvector do? So, oh, that's wrong. That should be pgvectorize. Whoops. So pgvectorize is a way to basically take the encodings and turn them into something that pgvector understands. And pgvector is basically the thing that adds vector abilities to Postgres. And that's why I asked beforehand, because all you raised, well, not everyone, but basically all of you raised your hands to say you know what pgvector is. So pgvector says, okay, now Postgres, you can do vectors. pgvectorize kind of makes that functional. So one of the things it does is I can say, okay, pgvector, actually, this part isn't pgvector. What I'm actually doing is, and the reason I brought up all the other terminology before, is I've got a question, right? Is Postgres the best database engine? We know the answer is true, but what would the LLM say? And then you can take a model name, for example, and say, turn that into a vector for that model. Now think about what would happen if you did that for every row in your database. Let's say it's like some text or some blogs or some products or whatever. They would turn into the same language, and then to find records, you would just have to take a user question or a product comparison, use the same transformer on it, and then figure out which vectors that you stored in your data are closest to that user question. It basically replaces full text search, in my opinion, right? So that's one thing you can do with pgvectorize. You can just have it encode any old arbitrary string. The other thing you can do is give it a table name and some criteria like which columns have the data you're looking for, and then have it build embeddings vectors for every one of those columns. It basically concatenates them together and then creates a vector for each one, right? And check this out. I'm going to emphasize that even more, right? So a lot of the extensions you see out there, like the one that AWS likes to tout, and I think even the one from Microsoft, they do it by putting triggers on your table so that when you do an insert or an update or whatever, it immediately modifies the embedding. And you know what that does? It makes your updates slow as hell, right? Because every write now has to go to the, it has to invoke the transformer, and transformers are big ass arrays that it has to combine everything, and you're ending up with a result that way. So don't do that. What this does is the PGMQ is an extension that Tembo also wrote. And what it does instead is it actually creates a queue, and every time you do an insert, update, or whatever, as long as you use a particular syntax, which is this syntax here, when you say real time, it means use a queue. But anyway, what it does is it puts everything into a queue and then updates in the background. A queue reader, a worker in the background for Postgres will follow that, and anytime the queue has something in it, it does a select for update, so there's no stampede problem. And it goes, okay, I've got an embedding I need to update, and it just does it eventually. So you've updated your data, the embeddings eventually update, and then you can search the embeddings using other functions we provide, like this one. I can search the vectors I've created, right? Because it knows where the embeddings are. It knows the table that I create, like the job name that I tagged it with. It knows the columns I'm looking for. And now when I ask, is Postgres the best database engine, it searches the embeddings, grabs the 5 results that match it the closest, and then just gives them back to me. I've now written a search application without knowing anything about RAG, anything about PG Vector, anything about embeddings. All I need to have is an account with OpenAI or something, and I have to know the name of the model I'm using. So the other thing you can do, instead of just doing a table and building vectors on it, is you can build a whole RAG stack. And this is important because it knows the difference between searching just a table or searching a table in a way that I'm going to take the results from the search and then feed them into an LLM immediately. So when I say retrieval augmented generation, what it's actually doing is it's doing this step here. It's maintaining the embeddings, but when you do a RAG search then, it's taking those results and then feeding them into an LLM immediately. So your top 5 or top 3 or whatever results come back, that becomes part of your prompt. So you say, is Postgres the best database engine? It will match the elements here, like there's my query for the RAG search. It will find the top 3 results. So basically the references, the blogs, or whatever that I pulled back, feed them back into the LLM along with my question, is Postgres the best database? And then it will come back with a response immediately. And then in this case, we return a JSON object, which includes the sources that it found, which ones were the best match, so that we know what we fed the LLM. And it also comes back with a field called chat response, which I've just pulled out here, and that would be the answer. Because it's just a Postgres JSON thing, which is great. We all love Postgres JSON. And all you need to get it to work is, like I said, give it an OpenAI token, and you're done. Or, and here's the crazy part, this is the thing I asked for, and he put it in there. Or you can use Ollama or some kind of VLLM, which is a compatible API for OpenAI, basically. And you can attach that to any model you want. Llama 3.1, Wizard, like any of the other models out there that are very popular, you can just have it search locally. And your query will never go out to the internet. It'll never hit OpenAI. It'll never even leave the server. In Tembo's case, we actually built a product that works in the same Kubernetes cluster, so your system will query a local node that's in the same Kubernetes cluster, and you'll get responses from that instead of OpenAI. And all you have to do is tell it where it's looking. For the service we created for our hobby customers and other local tiers, that's all. They don't even have to do that. Once they install the stack, all that is set automatically to search from our local systems. So I actually have a blog for this. If you search for PG Friday, PHRIDAY, because it's a pun, and that's what I specialize in. So, all right, if I were to build a RAG app, what would I do? Well, this is how they work, right? Either puts in a prompt, goes in the transformer, some article text I've loaded it with before also goes in the transformer, gets turned into embedding, stored in the database. That gets searched, sent to OpenAI or whatever, gets back to the user. Boy, I love draw.ai, right? Or sorry, draw.io. Great site. So this is what it basically boils down to. The app side, I load all my data in, pass it through transformers. User side, take my question, put it through transformer. But you'd have to do all of this. If you didn't have some kind of extension to do it for you, your app would have to do all of these things. Have some kind of API for it. Here it is in the long form, right? Got to parse the embedding, generate the embeddings, transform the input. Those are all the steps. Or, here's a good part, or I can do that, right? Which would you rather do? Put in your token, initialize your RAG stack, and just call RAG search. And you're done. I actually did a 2-part blog series where I did this. The first one had like 100 lines of Python code, right? And that was just for doing the RAG search and doing the embedding generation and blah, 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 creating the prompt. It was ridiculous. When I did the second part where I'm like, okay, now let's do PG vectorize. The blog was like 1/3 of the length, and it was faster. So if I were to do this, like imagine for an instant, we have a bunch of articles we're trying to encode, okay? I'm going to go a step further and create article chunks. So the thing about embeddings is they're very context sensitive. If you put it more than like a paragraph in there, they start to get lossy. And you start to get, the vectors are kind of fuzzy, they aren't quite as accurate as they used to be. So one of the techniques you can do is break your content into paragraphs or some kind of relevant chunks, and then you embed those instead. And then with a join, you can come back to the original article, yada, yada, SQL. And now I'm doing my init RAG on the chunks. Very subtle difference, but it looks familiar because I already showed a slide that has the init RAG there. And then I included this because the chunking is very important. If you've ever played with LangChain and Python, they actually have a system for doing text chunking for you. And a lot of libraries have this. LangChain is just very popular, so I figured I would use it. Plus, our documentation and blogs from Chuck, Adam, the guy who wrote PG Vectorize, used this as well. Actually, he's the one that told me about the technique. I was like, wow, that's awesome. Because before, I was feeding it my entire blog. Like, every article would get one vector, and I was just getting horrible results. And the chunking helped it substantially. Plus, they're smaller, so they take less time to calculate. So now my whole RAG app is just this. My blog chat thing that I did with my chunks, I asked my question again, and I decode the chat response, and there's the JSON result there. And that sentence apparently not that sentence, but that content showed up in one of my slides in my content. And it was actually like I was talking, that particular article was one I was talking about how popular Postgres was and how awesome it was, yada, yada. And that was in there. So one of the top 3 results in that particular search was Postgres is awesome. It's won a whole bunch of awards. Here's an example of it. And instead of making up an answer like an LLM usually will, if it doesn't know, like it'll just hallucinate something because the word tokens are in a cloud and they're nearby other stuff, and it will confidently pick out the wrong answer because it sounds right, or the probability said this token comes next. But now I can say, with retrieval augmented generation, use this as a reference instead of what you would have just come up with on your own. And that's why people like RAG, because it basically stops hallucinations in their tracks. And to sum it all up, and this is why these 20-minute talks are kind of handy. They're like basically just a show and tell. They're a long version of a lightning talk, right? If you can write queries, you can do AI, or at least the current approximation of AI. There are longer talks that are more interesting and talk about different techniques like feedback loops, and instead of doing the retrieval augmented generation, you send the query to an LLM first to get its interpretation of what the question would have been, and then vectorize that, and you get better results when you send it into your search system. That's not in there, at least not yet, but maybe eventually. So there's my contact information. You can take a picture of that or ignore it as to your. My slides will be published as the video will as well, so we probably don't have to be too worried about it. And I was told to put the slide in here. Oh, sorry, I saw someone with a phone. And I was told to put the slide in here because, oh, QR code, nice. So we do have something that's higher than the hobby tier, which is our kind of experimental free trial system. We give you like $300 of free credit, and you can just like spin up a large AWS, I don't know what a $300 equivalent would be for like a month. But you can spin up a large instance and then play with it to your heart's content up to a certain extent. And hopefully you have a company and you want to like maybe sign up with us, but you don't have to. But basically that's what we're kind of doing as our advertising campaign right now. Set something up, look at Postgres, play with the AI stack, play with our PG vectorize system and the other stacks we provide, like the geospatial and whatnot. That's really it. Sweet and simple. Questions? Yeah, so what the search does is it knows that you're going to vectorize that text and then search the vectors you already have. And that's one of the reasons when you do a search, you have to give the job name. Because when I vectorized it initially, I had to say the job name, right? What it's actually matching on when you do a search is it looks for some tables in the background, because when you do a vector, an embedding, what you're actually doing is you're creating another table, and then one of the columns in there is called embedding. And we're just straight up storing the embedding that we saved from PG vector. So we do a join between the original table and the vector table. We find out, we turn your search terms into another vector, find the embedding that matches it the closest, and we know what the source table was because we told it. So that's how we get all the content. And then we can feed those results back into an LLM, which is how the init RAG stuff works. It's indexed. It's usually indexed with HNSW, I think. Yeah, it's all PG vector under the hood, which is why I said like if you have to not only have you would normally have to know how to use PG vector, and you have to do all this stuff yourself, or just let PG vectorize do it for you. And the thing that and the reason I brought this up and I gave it its own slide, right, is because I remember watching the Microsoft like expo they did a few months ago, and they were like, "Oh, we've got this cool extension that it'll keep your embeddings up to date." And then I found out that it just uses triggers. Like when you do an update or an insert, it just generates the embedding right there. I'm like, "Oh my God, that's going to be so slow." And then I remembered that hey, our PG vectorized product, it actually builds a queue. Or if you don't want to do it instantly, like every time you do an insert or update, you can set it up with cron. It includes the PG cron extension also as a system, so you can set it up to like run every 5 minutes and update any embeddings that have changed data, so you don't have to worry about every time you do an update of your product inventory or add a new blog or whatever. Also, each one of those updates have to cause a bunch of latency from the update or insert or whatever write process you're doing. So I encourage you to look at PG vectorize. It's pretty awesome. Anything else? Yeah. Yeah, so when I said you have to provide your LLM key here, you can provide your LLM key to OpenAI. And if you do that, we go, okay, this guy provided an OpenAI key. Let's reach out to OpenAI using this token and we'll ask it the question. Or if you have something that's compatible with VLLM, like Ollama, for example, Ollama will let you pick a model. And as long as you initialize it, it provides an API that's network available. And then if you do that instead of asking OpenAI, it'll ask that URL, whatever it is, instead. So if you have one of these set up in like a local cluster, or you want to ask Claude because it has a compatible, right, it has a compatible API path, it would use this instead. So you can do either. And that's the other thing that I had never seen another extension do. Like if you don't want it to ask OpenAI, you can ask a local copy, or you can just give it an arbitrary URL, right? Like your friend is running like a product he created in his basement, and it does OpenAI stuff. And as long as it has that API, then you can use that instead, and it'll work. Anything else? Awesome. Been great having you guys.